Our solar system is a vast and diverse place filled with planets and moons of all shapes and sizes. Each celestial body holds its own unique characteristics and mysteries, waiting to be explored and understood. Among them, Venus stands out as a particularly intriguing case. Its bright reflective clouds make it one of the most visible objects in our night sky. Often called Earth's twin, Venus is similar in size and composition to our own planet. Both planets have similar densities and chemical compositions, making Venus a fascinating subject for comparative planetology. However, Venus harbors a hostile environment, shrouded in a thick atmosphere of carbon dioxide and plagued by scorching surface temperatures hot enough to melt lead. The planet's surface is marked by volcanic activity and crushing atmospheric pressure. Yet beneath this harsh exterior lies a world of possibilities. Scientists believe that Venus may have once had conditions suitable for liquid water and perhaps even life. Despite its current state, Venus holds the potential for transformation, a chance to become a second home for humanity. The idea of transforming Venus into a habitable world has captured the imagination of scientists and visionaries alike. This process, known as terraforming, involves engineering a planet's environment to make it suitable for human life. It would require altering the atmosphere, temperature, and surface conditions to create a stable and life-supporting ecosystem. While a daunting task, terraforming Venus is not beyond the realm of possibility. Advances in technology and our growing understanding of planetary science bring us closer to making this dream a reality. By understanding the challenges and harnessing the power of science and technology, we can envision a future where Venus is transformed from a scorching hellscape into a vibrant and life-sustaining world. This transformation would be a monumental achievement in human history. The journey to terraform Venus will be an epic endeavor, spanning generations and demanding unprecedented collaboration and innovation. It will require the combined efforts of scientists, engineers, and policymakers from around the globe, yet the potential rewards are immeasurable. Successfully terraforming Venus could provide a new frontier for human expansion and a backup location for humanity in case of catastrophic events on Earth. Imagine a future where humanity has expanded its reach beyond Earth, establishing a thriving civilization on a once inhospitable world. Cities could rise under the Venusian sky and new ecosystems could flourish. This is the promise of terraforming Venus, a testament to the boundless potential of human ingenuity and our enduring quest to explore and inhabit the cosmos. It represents our unyielding spirit of discovery and our desire to push the boundaries of what is possible. The first hurdle in terraforming Venus lies in its incredibly dense atmosphere, a thick shroud of carbon dioxide approximately 90 times denser than Earth's. This dense layer creates an immense pressure on the surface, making it extremely hostile to any form of life as we know it. This dense atmosphere acts as a giant blanket, trapping heat and contributing to the planet's runaway greenhouse effect. The surface temperature on Venus can soar to a scorching 900 degrees Fahrenheit, hot enough to melt lead. To make Venus habitable, we must find a way to thin this oppressive atmosphere. This involves not just reducing the carbon dioxide but also managing the extreme temperatures. One proposed method involves deploying giant orbital mirrors to reflect sunlight away from Venus, effectively reducing the amount of solar energy reaching the planet. These mirrors would need to be massive, spanning several kilometers in diameter. These mirrors, strategically positioned in space, could gradually cool Venus's atmosphere, allowing some of the carbon dioxide to condense and fall as rain. This process would be slow, but could significantly alter the atmospheric composition over time. Imagine a constellation of shimmering mirrors gracefully orbiting Venus, slowly but surely diminishing the planet's intense heat. This would be a monumental engineering feat, requiring precise calculations and advanced technology. Another intriguing possibility involves using specialized spacecraft equipped with lasers to break down carbon dioxide molecules in the atmosphere. These lasers, powered by solar energy, would target carbon dioxide molecules and split them into carbon and oxygen. This method would directly reduce the greenhouse gases. The carbon could then be sequestered or used for other purposes, such as building materials or even fuel for other space missions, while the oxygen could contribute to a future breathable atmosphere. This would be a crucial step towards making Venus more Earth-like. Picture a fleet of high-tech spacecraft, their lasers firing beams of intense light, gradually transforming the composition of Venus's atmosphere. This would be a coordinated effort, requiring international collaboration and significant investment. These are just two examples of the innovative solutions being explored to tackle Venus's dense atmosphere. Scientists and engineers are continually brainstorming and testing new ideas. While the challenges are significant, the potential rewards are enormous. Successfully terraforming Venus could provide a new home for humanity and valuable insights into planetary science. By thinning Venus's atmosphere, we can begin to tame the runaway greenhouse effect and pave the way for a more temperate and habitable world. This vision of a transformed Venus is both ambitious and inspiring, representing the next frontier in human exploration and ingenuity. While thinning the atmosphere is crucial, we must also address Venus's extreme temperatures, which average a scorching 464 degrees Celsius, or 867 degrees Fahrenheit. This intense heat is a direct result of the runaway greenhouse effect, where trapped solar radiation has turned Venus into a planetary oven. To make Venus habitable, we need to cool it down significantly. One promising approach involves deploying a large-scale sunshade, a giant structure positioned between Venus and the Sun. This sunshade, made of reflective materials, would act like a cosmic umbrella, blocking a significant portion of solar radiation from reaching the planet. Imagine a vast shimmering disk, strategically placed in space, casting a cooling shadow over Venus. Another possibility is to deploy a network of smaller orbiting mirrors to reflect sunlight away from Venus. These mirrors, working in concert, could create a cooling effect, gradually reducing the planet's overall temperature. Picture a constellation of mirrors, strategically positioned around Venus, reflecting sunlight away and slowly dimming the planet's intense glare. These cooling methods, while ambitious, are within the realm of possibility given our current technological trajectory. By shielding Venus from the sun's intense heat, we can create the conditions necessary for temperatures to drop to more manageable levels, paving the way for liquid water and a more hospitable environment. Section 4. The elixir of life bringing water to Venus. Water, the elixir of life, is essential for any habitable planet. While Venus may have once possessed oceans of water, today, its surface is bone dry. To transform Venus into a thriving world, we need to find a way to replenish its water supply. One intriguing possibility involves capturing and redirecting icy comets or asteroids from the outer solar system. These celestial bodies, rich in water ice, could be carefully nudged into Venus's gravitational pull, delivering vast quantities of water upon impact. Imagine a celestial ballet, as icy comets are guided towards Venus, their impact releasing torrents of life-giving water. Another approach involves harnessing the power of chemical reactions to create water from scratch. Venus's atmosphere contains trace amounts of hydrogen, a key ingredient in water. By introducing catalysts or using specialized machines, we could potentially trigger reactions that combine hydrogen with oxygen, producing water as a byproduct. Picture vast industrial facilities on Venus, their machinery humming as they diligently produce water from the planet's atmosphere. Replenishing Venus's water supply will be a monumental task requiring ingenuity and technological prowess. However, the rewards are immeasurable. With the presence of liquid water, we can begin to envision a Venus transformed, a world where oceans shimmer beneath a cloudy sky and rivers carve their way across the land. Section 5. Breathing life into Venus, creating a breathable atmosphere. While thinning the atmosphere and cooling the planet are crucial steps, we must also address the composition of Venus's atmosphere itself. This is a complex and multifaceted challenge that requires innovative solutions and a deep understanding of atmospheric science. Currently, the Venusian atmosphere is composed primarily of carbon dioxide, a gas toxic to humans. This dense layer of carbon dioxide not only makes the air unbreathable, but also contributes to the planet's extreme greenhouse effect. To make Venus truly habitable, we need to convert this carbon dioxide-rich atmosphere into one rich in nitrogen and oxygen, similar to Earth's. This transformation would create an environment where humans and other Earth-based life forms could thrive. One promising avenue involves harnessing the power of nature itself. Natural processes, such as photosynthesis, have been purifying Earth's atmosphere for billions of years. Certain types of microorganisms, known as extremophiles, thrive in extreme environments and possess the remarkable ability to convert carbon dioxide into oxygen through photosynthesis. These resilient organisms could be key players in our efforts to transform Venus. By introducing these hardy microorganisms to Venus's atmosphere, we could potentially trigger a gradual but significant shift in atmospheric composition. Over time, these extremophiles would multiply and continue their work, steadily increasing the levels of oxygen. Imagine microscopic life forms, diligently working in the Venusian atmosphere, slowly but surely transforming its toxic carbon dioxide into breathable oxygen. This biological approach offers a sustainable and self-perpetuating solution. Another approach involves deploying massive, industrial-scale machines designed to capture carbon dioxide from the atmosphere and convert it into oxygen. These machines would operate continuously, accelerating the transformation process. These machines, powered by solar or other renewable energy sources, would act as giant air purifiers, steadily transforming the composition of Venus's atmosphere. Their operation would be crucial in maintaining the balance of gases needed for a breathable environment. Picture vast, futuristic factories dotting the Venusian landscape, their machinery humming as they diligently cleanse the air, making it suitable for human lungs. These factories would symbolize human ingenuity and our ability to engineer solutions on a planetary scale. Transforming Venus's atmosphere into a breathable mixture of nitrogen and oxygen will be a monumental undertaking, requiring a combination of biological and technological solutions. Both approaches will need to work in harmony to achieve the desired outcome. Yet the rewards are immeasurable. A transformed Venus would not only be a new home for humanity but also a testament to our ability to overcome seemingly insurmountable challenges. With each breath of fresh Venusian air, we will be reminded of the transformative power of human ingenuity and our ability to reshape entire worlds. This endeavor will mark a new chapter in our journey as interplanetary explorers and pioneers. Section 6. A magnetic shield protecting Venus from cosmic rays. While Venus possesses a substantial atmosphere, it lacks a global magnetic field like Earth's. This magnetic field acts as a protective shield, deflecting harmful cosmic rays and solar wind that can strip away a planet's atmosphere and pose a threat to life. To ensure the long-term habitability of Venus, we need to find a way to create an artificial magnetic field. One ambitious proposal involves constructing a giant superconducting ring around Venus's equator. This ring, carrying a powerful electrical current, would generate a magnetic field capable of deflecting harmful radiation. Imagine a colossal ring, encircling Venus like a celestial guardian, its invisible magnetic field protecting the planet from the dangers of space. Another possibility involves deploying a network of smaller, interconnected satellites around Venus. These satellites, each generating its own magnetic field, would work in concert to create a protective bubble around the planet. Picture a constellation of satellites, orbiting Venus in a synchronized dance, their combined magnetic fields forming a shield against cosmic rays. Creating an artificial magnetic field for Venus is a daunting but not insurmountable challenge. By harnessing the principles of electromagnetism, we can provide Venus with a vital layer of protection, ensuring that its newly created atmosphere and burgeoning life are shielded from the harsh realities of space.